Picture a mass extinction, and you likely imagine a sudden flash of light, a colossal asteroid breaking through the atmosphere, sending a silent shockwave across the planet and wiping out life in an instant. Modern biodiversity loss follows a slow, unfolding timeline, adhering to a scientific reality far removed from that apocalyptic imagery. If we wait for the moment the last individual of a species dies, we miss the actual mechanics of how life disappears. Scientists describe this earlier stage as biological erosion, the gradual shrinking of populations and ranges long before the final loss. To understand the global extinction crisis, we have to look past the final death rattle. We must deconstruct the anatomy of an extinction step by step. Fixating on a single dramatic moment obscures the invisible mechanical erosion that is already pulling apart global ecosystems. The timeline of a human-driven extinction usually begins with the physical space life needs to survive. We clear land for agriculture, expand urban development, and extract resources. Modern land conversion is absolute. Entire biomes are stripped to the soil to feed human industry, replacing complex ecosystems with bare earth. Human activity fractures continuous ecosystems into isolated islands surrounded by hostile terrain, a process known as fragmentation. Inside these disconnected patches, wildlife populations become physically trapped. They can no longer migrate, hunt, or mix with other groups. These isolated populations eventually suffer from genetic bottlenecks. The groups become too small and the gene pool too shallow to remain viable. Protecting a small, fenced-off patch of green is biologically insufficient if the underlying network is shattered. In habitats that remain physically intact, human activity still drives biological collapse through direct extraction, like hunting and overfishing. Industrial marine operations empty out wild populations at a staggering volume to feed global supply chains. This creates defaunation, a severe population collapse where a species technically still exists, but its numbers are too depleted to perform its ecological role. The global wildlife trade and targeted poaching accelerate this process, pulling high-value animals out of their environments by the thousands. Defaunation creates ghost ecosystems, forests or oceans that look pristine to the naked eye, while their essential ecological workers are actually gone. Populations already fragmented and thinned out by defaunation are highly vulnerable to external shocks. Global trade introduces invasive species to these weakened environments, disrupting systems that evolved without these specific predators or competitors. Climate change acts as a threat multiplier, forcing habitable temperature zones to shift faster than trapped organisms can migrate. Because life relies on an interconnected network, these pressures trigger co-extinctions. The loss of a single foundational species, like a pollinator or apex predator, sets off a chain reaction of secondary losses. When a critical node in a food web collapses, the organisms that relied on it for survival lose their support system and vanish as well. These human-driven pressures sever the invisible ecological relationships that once held entire biomes together. The most unsettling reality of this process is extinction debt. The extinctions resulting from today's habitat loss may not fully materialize for decades or even centuries. This chart shows the mathematical delay between human action and biological consequence. While the red line shows a sudden drop in habitat, the dotted blue line reveals that species counts decline much more slowly. The damage is done, but the bill hasn't come due. This delay eventually leads to biological homogenization. Diverse ecosystems are replaced by a simplified world dominated by human-tolerant species, while specialized life vanishes. This homogenization directly threatens human welfare. We rely on complex biological networks to maintain crop resilience, purify our water, and stabilize the food systems that sustain our civilization. The Sixth Mass Extinction is uniquely driven by the activities of a single species, us. Unlike a sudden asteroid impact, human economic, agricultural, and energy systems can be redesigned. Halting the timeline requires reconnecting fragmented landscapes, shrinking our agricultural footprint, and shifting focus toward preserving entire ecological networks. Restoring biological connectivity provides trapped populations with the room they need to migrate, mix, and adapt to a changing planet. Recognizing extinction as a slow, mechanical process is our greatest advantage. It means the final outcome isn't written yet, and we still have time to hit the brakes.